Okay, so another rational function. We have y equal to 3x squared minus 3x minus 6 over x squared plus 8x plus 16. And again, in general, I usually start by factoring it, not canceling, but factoring. So we could certainly take a 3 out of the numerator. We're left with x squared minus x minus 2. Denominator we'll leave alone at this point. And then both of these trinomials can factor. So we have the 3, and that would be x minus 2, x plus 1, all over x plus 4, x plus 4. Okay, now notice there is no cancellation anyway, but if there were, I still would not do it at this point. Okay. All right, so we run through our information here. So first we're looking at domain. We throw out any numbers that make the denominator 0. So in this case, clearly x cannot be negative 4. Those would be the zeros of our denominator. So for part B, the question is, what happens at negative 4? Would there be a vertical asymptote or a hole? Okay. So remember, how do you check what's going to happen? The only places we need to check, the only places that a vertical asymptote or a hole could occur, is that value is not in the domain. So we try to figure out what is happening at x equal to negative 4. Okay, we know the function's undefined there. Okay, but to determine if it's a vertical asymptote or hole, we sort of decide, okay, how is it undefined? We know it's a 0 denominator, but what happens to the numerator? Okay, now remember, if there were a reduced form, that's where we would use it, but in this case, our f tilde, at negative 4 is the same as f of 4, because again, it doesn't reduce. So if you plug 4 in, we get 54 on top, clearly 0 on bottom. We knew the bottom would be 0, but if the top is not 0 and the bottom is, for the rational functions, we know we get a vertical asymptote. So that's f at negative 4. Okay. For horizontal or oblique asymptotes, remember we look at the leading coefficients. So we have 3x squared over x squared. The degrees are tied, which means in the long run, when the lower powers don't matter, we wind up near 3x squared over x squared, which cancels to just be 3. So we have a horizontal asymptote, the horizontal line y equal to 3. Again, when the degrees are tied, we take the ratio of the leading coefficients, in this case 3 over 1. Since there is a horizontal asymptote here, we can decide if our graph crosses that asymptote. Okay, our rational functions will never cross the vertical asymptotes, but they could cross horizontal or oblique ones, and we just want to know if they do or not. So remember, we need to figure out when this function, 3x squared minus 3x minus 6, all over x squared plus 8x plus 16, when does that ever equal 3? Okay, so a clear fraction, so we'll bring this part up here. So we have 3x squared minus 3x minus 6, and then when this comes up, I'll distribute the 3. I get 3x squared plus 24x plus 48. Subtract away the 3x squareds, those will be gone. I'll add the 3x over here, so that's 27x plus 48. Subtract the 48, it's negative 54, divide, and I get x equal to negative 2. Okay, so there is a point when I plug in negative 2, the output's going to be 3, and that will be a point at which, the only point at which, the graph should cross my horizontal asymptote. Okay. And then finally, intercepts, again, just to give us a few points. We already have a vertical asymptote, this 1 point, so we get a few more points from intercepts. So again, x-intercept, we know should look something like something comma 0. So we need the function to equal 0. So again, we take and solve our function 3x squared minus 3x minus 6 over x squared plus 8x plus 16 equal to 0. Okay. We can multiply both sides by the denominator, so 3x squared minus 3x minus 6 equals 0. Again, the only way the fraction can be 0 is if the denominator is 0. We already factored this, we already factored this to start, so I'll just copy that from above. And so clearly at 2 or at negative 1, we have intercepts. So we have 2 comma 0, negative 1 comma 0. Okay. And then finally for y-intercepts, right, we just plug in 0. So we evaluate the function at 0, so our numerator becomes negative 6, our denominator becomes 16, or negative 3/8. So for the y-intercept, we have 0 comma negative 3/8. Okay. All right, so then we take all this information and then we'll get a graph. All right, so the first thing we found out though is x cannot be negative 4. And we found out in part B that there's a vertical asymptote there, so we'll put that in. Then we also found a horizontal asymptote at y equal to 3. So we put that in. Remember, asymptotes are nice guidelines for your graph. So the graph will start over here and will end over here. And then when we run into the vertical, we either shoot up towards infinity or down towards negative infinity. Okay. And now we have a few points. We have the point negative 2, 3. So we cross the horizontal asymptote there, and maybe almost as importantly, we don't ever cross it again. And we have a couple intercepts. So we have an intercept here at 2, 0. Negative 1, 0. And then we also have our y-intercept, remember, at 0, negative 3/8. So just down here a little bit. Okay. So we have a lot going on in here. Okay, remember, we never cross the axis except for these 2 places. Okay, not a lot going on left of negative 4. Okay, notice there's nothing back here. Okay, well, which probably means we only have 2 choices. We have to start over here, either right above or below. Okay, but if we start below, right, then if we keep going down, we'd cross the axis. We're not supposed to. We only have these 2 x-intercepts, so we can't do this and come down. Could we start right below and go up? Well, no, because again, then we'd have to cross the horizontal asymptote, and this is the only place we cross the horizontal asymptote. So we have to start above and then simply head up. Okay. Similar over here, it appears, right, we can't go up because we have to get to this point. If we were going to try to go up to get to that point, we're crossing the axis. These are the only 2 places we cross the axis. So we'll come down, try to hit these as smoothly as possible. And then we can't go up through it, right, because we only cross it once. So we'd wind up over here.